As we're working through our class of statistics, it's going to be important that we can summarize a large data set with one or two numbers. One thing we're often interested in is how we can measure the center of the data set. And the most common center of a data set is this thing called the mean. The mean is one of the measurements of the center of data. It's often thought of as the average. Even though all measures of center can be called average, the mean is the one we think of the most often. The formula for the mean for a population, which will use the symbol, the Greek letter mu, to represent the mean of the population, and the sample. If we're working with a sample statistic rather than a population parameter, we use the letter x with a bar over the top of it to represent a sample. Both the population parameter and the sample statistic for the mean have the same formula. The formula for the population parameter mu is the sum of all the x values divided by the population size. A little bit of vocabulary here. We pronounce the population parameter mu as mu, meaning the mean of the population. This funny letter E is the Greek letter sigma. Sigma represents the sum. It means add up all the things. We use that symbol quite a bit in statistics to mean add up all the things. The x is all the individual values. And then capital N will represent the population size. You'll notice that the formula for the sample statistic x bar is very similar. It's the sum of all the x's divided by a lowercase n. And while it really means the same thing in general, the x with the line over it, we're going to call that x bar. It's going to represent the sample mean. The sigma, the funny letter E, is the Greek letter sigma, still represents the sum. The x still represents all of the values. But we use lowercase n because the lowercase means it's a sample, not a population, but it's the sample size. Same idea for both of them, though. So we add up the values and divide by the number of things we're working with. So for example, if I asked a bunch of people the number of speeding tickets, they have received this year, I might end up with the following data. 1, 1, 1, 2, 2, 3, 4, 4, 4, 4, 4. Nobody with zeros. This is a speed demon group. Since I didn't interview all the people in the world, just a small group, this is a sample, so I'll use the x bar formula. And to get x bar, we add or sum up the individual x values, or we add up the individual values. That's 1 plus 1 plus 1 plus 2 plus 2 plus 3 plus 4 plus 4 plus 4 plus 4 plus 4. And then we divide by the sample size. And if I count these up, there are definitely 11 values. So we divide by 11. If I put this in my calculator, I'm going to need to put parentheses around the numerator to make sure that we divide the sum by the 11. And when I do that, you should get 2.7. So it seems like this group of people have an average of 2.7 speeding tickets this year.